Welcome back, gangies. We're back once again. As you can see, I'm wearing the same outfit from yesterday because that's how we're moving right now. So if you find someone who also is doing LeetCode and they're changing their outfits frequently, you need to tell them to stop because they're wasting extra brain power, brain sauce they could be putting into more problems. And that's always a problem when we see it. So in the HCC, we're trying to stomp out any non-conformity. The HCC regime is growing in strength, and so if you see someone not conforming to the laws or suggestions, because we are in a cult, the suggestions of the Discord, then you should tell them to stop it. And that, okay, I'm gonna stop. I was gonna say we're coming for them, but that looks bad. That being the case, we do have some comments to help us stall before we have to go into the LeetCode. I actually am not that I'm not struggling that much to do the LeetCode recently. I think the switch from easy to medium is definitely very much welcomed. I think the easies were I think there was such low stimulation, it was actually kind of difficult. But I think over time, after doing this for so long, even though we've mostly been doing it for many days, but not that much time in totality. But I'd be curious to see how much time we spent doing LeetCode if someone were to do the math. I tried to ask ChatGPT to write a script to calculate this for my YouTube channel, but it required a little bit too much brain sauce, and I had no more brain sauce left, so I kind of just let it be. That being the case, I think we're a little less sensitive to low stimulation, but it's still there. I think we did easies for a while, and I'm surprised we even did as many as we have. Actually, when we actually sit back and look at it, we've done a lot of easies, which is actually kind of crazy. We literally have 309 easies done, which is pretty crazy when you think about it. I actually can't even imagine. It's actually kind of crazy. Most of the days that I'm doing this, I'm like, we're making no progress. Now that I'm thinking about it, we did 300 easies. And even though they aren't the hardest problems, still, some there. That's pretty cool. Hopefully we'll start to enter hyperbolic time space. And actually we were right. Because I thought, when we started doing the easies, I thought we would slowly get faster. And we actually did. We did reach an exponential speed. And that's pretty dope. But unfortunately, something about the faster we were going, the less, I don't know, it was just difficult. I think the more problems we did, the easier they became. Easier they became, the less, I guess, there was a challenge. But now I'm realizing maybe there are spells, it's just interesting. There are spells between which one, where I don't really realize that I'm using some aspect of the process to keep me interested. I didn't realize I was actually attached to the difficulty of the problem. I didn't even know that until easies became too easy. So we probably could have kept doing the easies anyway to retaliate against this mentality and do it anyway. But it's probably time to go to mediums, and it could be fun. So I'm cool with that. Maybe we'll alternate, right? After we do enough mediums, we get stuck enough, right? Then we'll go back to easies and so on. Whatever journey we take, will be our journey, right? So that being the case, we do have some comments to help us stall a little bit longer. And we have a comment from a legendary part-time author, entrepreneur, computer toucher, best friend, visionary, as well as heartfelt author, Wilderness. Also, legendary anime, also legendary scene from the show. So every time Wilderness says, every time I see your video in my subscription, I'm reminded to get off. Thank you, sir. Let's get it. True. This is really how it be. The same thing happens to me. If there were any regularity in these videos, they would probably help the channel, but we just do them when the time strikes. But sometimes I'll be in the zonking machine when I'm using I'm on my phone or my computer and I'm like, and, I'm scrolling. I'll see some video about someone getting to it, someone getting to the business, and then I'm like, you know what? It's time to get back to work. can't even breathe right now. And then I'm like, oh man, we got to get back to work. But it's crazy how it be like that. We really only have a few passing moments when we escape the Zonk machine and the tendrils of the social media and corporation capital complex regime removes its tendrils from the base of our cerebellum, and then we awake, wise, eyes open to see dystopia. And then from there, we're like, okay, we got to get to work. But the tendrils only escape the base of our cerebellum occasionally, so we got to jump into it. We got to strike when the lightning strikes. When you wake up from the zonk sleep, it's your only time to strike. So it kind of just be like that. But this is a funny comment, and same. Sometimes I'll see people in the Discord chatting about getting to their problems. I'm like, oh man, we got to get to work. We got to get some work. And it's pretty cool because we actually have some people aiming for some pretty dope goals. So we have, I actually don't even know how to say the name, but we have this person called II, where there are 2 eye emojis or eye symbols. And they're next up to become a quant. So once they get in, they're going to open the back door, and all the HCC members will also slide in. And then we'll have control of the top quant position providers in the North American seaboard. And then once we do that, I mean, it's game over. So Elon and I and a couple other stakeholders have some ideas for this going forward that we're going to meet up about later. So I'll see you at the meeting with Emlon. Oh, we have a comment from Thomas. Thomas, the GOAT, visionary, part-time author, full-time best friend. LC17, one of the classic backtracking mid-level problems. Try LC93, LC79 for more taste of backtracking. This is beautiful. How do you have this map of backtracking problems in your head? I'm tempted to get a little more of a taste. It would be interesting to see. Thank you, brother. It'd be interesting to see, because the problems are all rated in terms of loosely categorized tags. But it'd be interesting if we could have a little more granularity in tagging. But the taxonomy of problems sounds like a critical undertaking. Maybe not for a human, but maybe for ChatGPT. So I actually had an idea to have ChatGPT taxonomize the corpus of LeetCode descriptions into like 30 categories that are a lot more granular than what is currently given on LeetCode. I mean, you could write a script for this and pay for GPT Premium and have it done. I think it'd be pretty cool as an intuition trainer, kind of like a V3. But it's been my project backlog for like 2 months now, so God knows when I'll get to it. So maybe someone else is gonna jump on it. But an intuition trainer for LC problems or interview problems in general would probably be pretty dope. And we do have some mechanisms available to automate some of this process, so that would be kind of useful. But we shall see. But awesome comment from T Wong as usual. Now that we're actually getting closer to doing the problem, the dread is setting in. I want to die. But we'll try it anyway. So today we're gonna set the timer for 30 minutes. I actually don't have a lot of sleep. I stayed up till 5 yesterday working on something for, actually it was like 5:30 working on something for work, and then I slept until 11. And then I got up for work exactly at 11. But somehow I'm still alive, so I'm relatively certain this problem is going to cook us, so let's just jump into it. Given an array nums of n integers, this is asked by Audible, which is actually pretty cool. Given an array nums of n integers, so we have n integers, return an array of all the unique quadruplets. Huh? That's not the problem I thought it was going to be. Return an array of all the unique quadruplets. So you have num sub A, num sub B, num sub C, num sub D, such that A is less than B is less than C is less than D. Actually, no. Such that A, B, and C are between 0 and N. A, B, C, and D are distinct. Okay, yeah, and A, num sub A, B, C, and D equals target. So we want the array of all unique quadruplets such that 4 numbers sum up to the goal number. This is a pretty crazy problem. So not only do we want to know how many ways we can sum up with 4 distinct numbers and it equaling the target, we actually want to know the numbers themselves. Unfortunately, nums is so long that it's probably not even, nums is so long it would be a pipe dream to try and generate an exhaustive outcome of all the different ways you can actually assemble this set of numbers into sets of 4. So it would be not a good idea to try that. So maybe we can do something else. So we'll say exhaustive generation equal dead. Other ideas, question mark. Maybe we could do like some kind of tiered version of a two-sum solution. If we take 2 numbers, for example, 1 and 0, we have 1. The question now can be rephrased as, can we find 2 numbers such that they add up to -1? If we phrase the question like that, I guess we could change it to, how fast could we find 2 numbers given 2 numbers that sum to a target? I think there's a way so what if we loaded, for example, we wanted to figure out if 2 numbers, how fast could we figure out for each number given a target, how fast can we figure out given 2 numbers, given a target and a set of numbers, we need to find 2 numbers such that they equal target. How fast can we do that? Well, you could take, if target was 4, you could take target and subtract it by the current number we're taking a look at, and then check if its complementary number exists in the list. If we had a map of all the numbers, we could do this in constant time. Okay, so we could say given two numbers and a target, we can find two numbers that sum up to target in approximately constant time. I think if we loaded all the numbers into a set, then we could iterate over all the numbers and we could say target minus number equals the complementary number. Then we can check if the complementary number exists in this set. The other thing we'd have to make sure though is that they're distinct. And I think we could do that. I think this works. I feel like this makes sense. So I think in theory we'd be doing this in, so let's just say we started at 1, right? We'd start at 1 in nums, right? And our target is 0, right? So then from nums we would go to 0 and we'd say, okay, well 1, 0. Right, now we're looking for two numbers such that they add up to be 1. Right? Two numbers such that they add up to be 1 that aren't 1 or 0. Or to add up to be -1. No, I wrote this wrong. Given a starting number and a target, we can find a complementary number that sums up to target in constant time. So given a starting number and a target, we can find the complementary number that sums up to target in constant time. Hmm. Oh, I just figured out a brute force solution, but that would be that would be n cubed time. I mean n to the fourth. Because we could always just wait, we could do this in n squared time, I think. What if we pre-compute pairs of values? For example, we pick up one, e.g., we pick up 1 comma z, we pick up 1, right? If we pick up 1, we know that the target we're looking for is 3 other numbers, looking for 3 numbers that sum to, we're looking for 3 numbers that sum to 0 minus 1, which is -1. Similarly, I think we could do this in n squared time if we generated all 2 number pairs. I think if we did that, if we generated all 2 number pairs, then we could simply check the 2 numbers we have into the map to check their complements. The only other problem is we'd have to make certain that we don't reuse indices. I feel like this makes sense. we would do n squared to generate all 2-pair numbers. Wait a second. No, couldn't you layer a second layer on top? Layer another layer on top. Don't we just now have to find two numbers? Two pairs of numbers that sum to target. For example, we could find 1 and 0, right? And then we could check to see if there's another pair in there. The array would be iterating over would have n squared items in it. But we could find the other pairs in constant time. I think this works. So paired nums would be an array of numbers right, and then we would iterate for I equals 0, I is less than nums dot length I plus plus. We could duplicate this and make it j. Once we do that, right, we can just say paired nums. Maybe we should, yeah, this one's a tough one. Right, we'll say it equals a new map of type number, right, which would be the sum of the two numbers, and then an integer array, which would be the indexes that number is created from. Here we would say paired map dot set. The issue is, this is a mess, because we'll have, for example, what if we have multiple methods, multiple ways? So, okay, we can do that. We'll make this an array. And it's going to be an array of tuples. It's pretty much the two numbers, right, that create that sum. So we'll say R is equal to paired map. First we'll add these two numbers together, num sub I plus num sub j. To get the sum, we'll say if paired map has the sum, right, then we want to do paired map dot get to get the array. Otherwise, we'll set it equal to an empty array. Then we can do r dot push onto the array I and j. Then we can set the sum equal to this modified array. And then from here we'll just add, we'll just do paired nums dot push sum on. From this point we know that, like we said earlier, given a number and a target, we can find the other number in constant time, or the complement. So we can do is say for const num of paired nums we're going to say the complement is going to be equal to target minus num. Here we'll say the answer is supposed to be an array of numbers we'll say if paired map has complement, then we want to say we want to get that now we'll have this complement value, which is going to be an array of pairs of numbers. Now that I'm looking at it, we probably want to do sum and we'll just call it the sum parents, and we can actually do it with paired map instead. One thing we could do to make this simpler you can also have the answer. I think that's what I'm trying to say here. Here we can return the answer. Need a way to know if the four numbers we have, the four indexes we have are distinct. Well, one thing we can do is in here is make sure that I never equals j. These are the complement indices. Now we have the sum indices and the complement indices, and we pretty much just need to, I guess we can just add them into an array and sort them. We're only going to be sorting 4 elements. I'm just gonna print ID array to make sure I'm even following this. Flatten's probably not even a thing. We'll duplicate this for complement indices. And then I'll just print this to see what we get. Okay, this actually looks good so far. Actually, this doesn't make any sense. Wait, this makes no sense. Why do I have two arrays in here? I think I see the issue. doesn't make any sense. We have two numbers that add up to a target. We have their indices. Now we just need to combine the indices and put them in a map. I feel like I'm fighting the language right now, not the problem. Now this should just be four, not four indices. If we haven't seen it, if we haven't seen, what did we call it? Scene IDs. number ID is just going to be idr.map. This is very ghetto. And we haven't seen number ID to answer dot push This makes no sense. I'm gonna be honest, but we're just gonna we pass a case this other one Yeah, we'll take a closer look at this tomorrow, but I think we'll stop there.